Okay, this lesson is going to be a little bit different than most that we've had. So welcome everybody. As you can see, this was a fun day today with it being my birthday. So I wanted to thank one of my former students, Miss Clark Courtney. She made me the happy birthday Nomi cake, and so all the gnomes decided to come out and wish me a happy birthday. So that would be a good question for our quiz tomorrow, since I don't have any guest teachers, unfortunately, tonight. So back to why this is a little bit of an unusual lesson. It's not because we're combining lessons, because we've done that before. But let me say quickly why it is that this video is covering both 3.5 and 3.6. Because if you look in your textbook, look ahead to the work that is in 3.5 and 3.6, you'll notice that in both cases, we're going to be solving equations. One-step equations, just like we've been doing. So this is just like the stuff we did back in Chapter 2 with equations, and then we get it again with inequalities. And now, in Chapter 3, we're going to do it yet again, except this time the numbers are going to be a little bit uglier. So instead of using integers, we're going to use some uglier decimals. And so 3.5, we're adding and subtracting uglier decimals, and 3.6, we're multiplying and dividing by uglier decimals. That's pretty much it. So let's go ahead and let's take a look at what we're talking about here. And so let's start with just a simple equation. Let's start with C plus 9.1 is equal to 3.75. Okay? And just like we saw before, we're going to write down the entire equation. And the way we're going to solve this is we're going to get rid of whatever is with the variable. So in this case, the variable is on the left, and it's being added to 9.1. So the opposite of adding, just like before, is going to be subtraction. So we're going to subtract 9.1 from the left. And now we're going to subtract 9.1 from the right side as well, but we're going to have to be a little bit more careful. Because as you can see, the left is going to be great. We get to do the little fruit ninja, and the plus 9.1 and the minus 9.1 cancel out, and we get C. But right here, we've got some problems. So having very little bit to do with the difficulty of the algebra, we've got some tough arithmetic here. We have a positive and a negative, and we're putting them together. And so we've got to go back to the three commandments, and we know that we need to actually find the difference here. So we're going to actually have to put the bigger number on top and the smaller number on the bottom. And because we have decimals, we need to make sure that the decimals line up. So notice the 9 and the 3 line up, the decimal point lines up, the 1 and 7 line up, and I'm going to have to add a 0 right here. Okay, that 0 wasn't really there. Let's add it in a slightly different color. We'll put it in the red just to emphasize that it wasn't there. We're going to find the difference here because we have positive and negative. They're different signs, so we need to find the difference. And show your work. Don't feel like, this is, pre-algebra, so we're above showing our work. So I can't take 5 away from 0, so borrow from the 1. I didn't actually have to. Hold on, let me fix that. Didn't have to borrow from the 9. We need to borrow from the 1. And we get 10 minus 5 is equal to 5. Now we can't take 7 away from 0, so now I need to borrow from the, from the 9 I get 8, and I bring a 1 over here, I get 10. 10 minus 7 is 3, and 8 minus 3 is 5. Now that's not done. That's just the difference. So the difference of 9.1 and 5.75 is 5.35. But we still need to go back to the third commandment. Who wins the tug of war? Well, the third commandment says, thou shalt keep the sign of the larger value. And in this case, the larger value is the negative, so the answer is going to be a negative 5.35. Again, the algebra here, where we subtracted 9.1 from both sides, is nothing new. All that we're really having to be careful of in this lesson is we need to be much more careful with our arithmetic, both with positive and negative numbers, and also with lining up decimals. Okay. The other kind of question that you'll see in section 3.5 will be subtraction equations. So suppose I start with x minus 7.81, and let's let that equal a positive 11. All right. So this one, again, let's switch to red. What am I going to do to both sides to get x by itself? I'm going to add 7.81. And so I got to come over here and also add 7.81. And now watch where I line things up. I'm going to put the 7 here, and then the decimal, 0.81. Okay? And I'm going to draw the big line underneath. We do this for addition and subtraction problems only. And now I can fruit ninja on the left, and those cancel out. I'm left with just x. On the right-hand side, if I want to go ahead and add a 0.00, when I'm adding, it's a little less important. I don't have to do it like I did up here. when I was borrowing, but it's probably a good idea to go ahead and put it in. And now let's go ahead and add from right to left. 0 plus 1 is 1, 0 plus 8 is 8, decimal, and then 11 and 7 is 18. So I get 18.81, and that's the answer for this one. Okay. Again, algebraically, in terms of solving these equations, we're not doing anything different. This is just more practice solving equations, except doing it with a little bit more tricky numbers. Okay. And again, showing your work. We've been talking about this since the day we first started solving equations. Showing our work is going to be crucial, and you can see how just little careless arithmetic mistakes could really cost you dearly in 3-5. Okay? Well, all right, let's fast forward. Let's go ahead and look at the problems of 3-6. Well, 3-6, again, is going to be just further examples of solving equations. This time we're going to be solving decimal equations that involve multiplication and division. So we're going to do the algebra just like we did before, but we're going to have decimals around. Okay? And so let's start with an equation like 0.8x is equal to negative 1.6. Okay? All right, so first let's ask ourselves, what's happening right now to the variable? Well, right now the variable's on the left, and the 0.8x means 0.8 times x. Okay, we don't see the dot there, might want to add it in. So how do we get rid of a times 0.8? We got to divide by 0.8. And if I divide the left by 0.8, I also have to divide the right by 0.8. All right, well, let's do some Fruit Ninja. 0.8 and 0.8, that cancels out, and I'm left with x on the left. Over here on the right, I have negative 1.6 divided by 0.8. Now, before I do the arithmetic, let's start with, is the answer going to be positive or negative? Well, if I have a negative divided by a positive, the answer is going to be negative. Okay? And if you need to go back and review your integer arithmetic rules from back 1.4, 1.5, 1.6, that would probably be a good idea. Those videos are still online, and you can go ahead and watch them. But again, a negative times a negative is positive. They cancel out. Negative divided by negative, same thing, cancels out. But if we have a positive negative, they're different signs, we do get a negative answer. Now for the division, we have 1.6 divided by 0.8. There's a couple ways to do that. One way is we can set up a long division. If you remember from 6th grade, you can't divide by a decimal. So you're going to take this decimal and move it to the right, to the number out front. And if you do that out front, you also have to do it in the back. So the 0.8 becomes 8, and the 1.6 becomes 16. Put the decimal on the top, and 8 goes into 16. Of course, it goes in twice. Another way to do it is you could have taken this original fraction before I divided and just multiply the top and bottom by 10. If you do that, you're going to get negative 16 over 8, which of course simplifies to negative 2. And that's my answer for this one. Sure enough, if I put negative 2 back in for x, you'll see that 0.8 times negative 2 will in fact equal negative 1.6. We've checked it, and we're good to go on. Okay? And again, notice the black equation that I had right here looks just like the same equations that we had last chapter. Okay? This is a multiplication equation, and you can see in red, we solve it by dividing. All right, finally, suppose I start with a division equation. Let's start with something like 5 is equal to s divided by 2.5. All right, now what's happening to the s? Well, it's being divided by 2.5. Always start with the variable side. Now this time the variable's over on the right, no big deal. We want to get the s by itself. So what we're going to do to get rid of dividing by 2.5 is we're going to multiply by 2.5. And of course, if I multiply the right side by 2.5, I've also got to multiply the left by 2.5. And I'm going to use parentheses to show multiplication. I still get to do Fruit Ninja. Over here on the right, s is divided by 2.5, then multiplied by 2.5. Of course, they're going to cancel out, leaving me with just s. And on the left side, 2.5 times 5. All right. So now, to finish this problem up, we need to multiply 2.5 times 5. A couple ways we can do it. I'm just going to do it a little cherry bomb over here. 2.5, oops, that looks like 2.6. 2.5 times 5. Go ahead and multiply. 5 times 5 is 25. Carry a 2. 5 times 2 is 10, plus the 2 is 12. And I had one decimal in the original, so I'm going to have one decimal here, and I get 12.5. So 12.5 is equal to S. And sure enough, if I put that back in for my variable, 12.5 divided by 2.5, think about that in terms of money. If I have $12.50 and I start handing out shares of $2.50 to my friends, I can do that 5 times. So yes, that checks. So there we go. So for 3.5 and 3.6, basically here's the deal. This is going to give you a chance to just really shore up the skills that we need to solve these equations, and it's going to do so in a way that really emphasizes how important it is to show work. So if you've been able to do these in your head up till now, now's the time where the arithmetic's going to catch up to us. So this is why it's so important to show every step. So we're going to write down the original equations. We're going to show very carefully what we're doing to both sides using the exact notation that we've talked about in class. We're going to show any arithmetic that we need to write with the problem. We're going to check our answers, and we're going to move on. We're going to try not to stop after each problem. So stop just long enough to check, and then as soon as you do, look back to your book, copy down the next equation, and move on. Okay, so that's it for 3.5 and 3.6. Looking forward to seeing everybody tonight. Thank you all for a very fun birthday today, and I look forward to seeing everybody in class tomorrow. We're going to go over problems from both 3.5 and 3.6, and then we'll talk about the metric system over the weekend. Keep in mind you will have a test coming up next Friday, so we really need to wrap up this chapter, so be thinking ahead and preparing. If you do have any questions, be sure to ask in class or to catch me outside of class. All right, everybody. See you tomorrow in class.